Hi, this is Doug Sparks again, and today I'm going to talk about the complexities of export controls and semiconductors and sensors. And for those of you who work in this field at an international level, or maybe you work at it with regards to the CHIPS Act, trying to get funding for that, you've probably noticed that there are just a plethora of new restrictions and regulations that have been issued in the last 5 or 6 years. You've got to become more familiar with all these acronyms, abbreviations, and regulations, and I'm going to give you just a high-level overview of some of those. So how did all the regulation and restrictions on semiconductor tools start? And it basically boils down to it's kind of become a derivative of arms control. Back when the Soviet Union and Warsaw Pact fell apart, there was a lot of concern about weapons going to bad actors, whether it's terrorists or the North Koreans, etc. So a lot of the European, NATO, and their NATO members and allies, and even Warsaw Pact members who wanted to cooperate with the West, put together this agreement in The Hague in the Netherlands. It's called the Wassenaar Agreement. It happened in the mid-90s. And it was mainly to control conventional arms and dual-use goods and technologies. There's 42 countries participating in this, and it's been expanded recently with some of the aggressive overtures that China has made with regard to Taiwan and the South China Sea and the Eastern China Sea. And it's been applied to semiconductor tools and semiconductor chips, etc. Now, export restrictions just aren't China. They've been around a lot longer than that. I mean, export controls have gone back, decades and decades. You could probably go back to, before World War II. There was export controls on oil and steel to Japan, and some say that actually triggered World War II. But more recently, these have primarily been focused at North Korea. Then it was Soviet Union, of course. Syria, Iran, then Russia, and most recently China has been added to countries that are kind of fall under the umbrella of export controls, particularly with respect to semiconductors. Now, there are lots of different regulations that control how a country acts back and forth. There's the World Trade Agreements, there's trade policy reviews that have to be taken, there's voluntary measures, and then there's prohibited and licensing requirements for some devices, particularly military devices. The goal is just to prevent the proliferation of weapons, particularly weapons of mass destruction, and destabilizing accumulation of conventional weapons and related materials. In the U.S., the Commerce Bureau of Industry and Security, the BIS, controls this. And it's the BIS that has been most recently putting restrictions on things like EUV, ASML photolithography tools, sub-5 nanometer chips from TSMC, for example, and then creating this, what we call the banned entity list. These are all part of something called the Foreign Direct Product Rule, and this dates back to the 1950s. Again, at that time, it was controlling trade to the Soviet Union and Warsaw Pacts. And it was trying to prevent American technology, particularly advanced technology, from getting to these, to the Soviet bloc. And it's continuing on, blocking other countries now from getting advanced technology, particularly if they work with a military organization. It was used for DTE, it was used for Huawei, it was also most recently used for YMTC's advanced NAND chips. It's been applied now to Belarus as well as Russia, particularly after Ukraine. And then we saw it impact one of the biggest industries in the US, that's semiconductor equipment, where KLA, Lam, and Applied Materials were all warned that regulations would be going into effect with regard to sales to Chinese fabs back in late 2022. Now, dual-use technology, I mentioned that a little bit earlier. Dual-use technology is the ability of something to be used commercially as well as militarily. Those of you in U.S. startups often have used this dual-use technology to get DARPA or DoD grants, whether you're working in MEMS or semiconductors. And now the same terminology is being used to prevent the export of technology to Russia, China, North Korea, etc. Examples of that are, the leading node semiconductors, less than 10 nanometers, because that can be used in surveillance. It can be used in artificial intelligence, perhaps quantum technology, 5G, 6G. So that's being restricted. And EUV lithography tools, as you know, were restricted. Things like inertial sensors, infrared sensors that are weapons related or guidance related are also on this restricted list. Here's an example close to my heart, since I've worked on gyros for over 2 decades now. When we first made MEMS gyros, the performance was horrible. We still had to check out with the US government to make sure we could export these 1 degree per second grade gyros. We did some assembly in Mexico and Singapore. We still had to go through all the paperwork to make sure we could ship these consumer grade parts to the assembly factory. Now you see with autonomous vehicles, ADAS, and drones, the performance of the gyros, the MEMS gyros, are rapidly getting into this dual use area where it could be some military overlap. So there have been restrictions placed on micro machine gyroscopes and accelerometers, for example. And there are ECCNs, export control classification numbers, for gyros, for infrared sensors. So if you're in that field, you got to look this stuff up and make sure, check the spec of your part and the spec that's listed there to make sure you can actually export this. And it's not just exporting it to China, for example, but even exporting it to Malaysia or Singapore for assembly is something you've got to look at and make sure you can do that, so that you're not exporting military grade equipment or parts. ITAR. Those of you who have worked in the US in this field may have come across ITAR regulations, particularly if you're selling to the government and you have to set up and certify that your factory is ITAR compliant. I had a startup and I had ITAR rules. We had government users of certain materials that we had to prove we were ITAR compliant, and since we were in the US, we had US citizens working there, all the documentation was controlled. We were able to deal with these military related products. So again, look at the compliance and regulations if you want to get into that, and that's just another thing you need to be aware of, particularly if you want to work in this niche. Now, there are penalties. Most people think, oh, it's just a government regulation, so they'll slap you on the wrist. Well, there are companies that have been fined hundreds of millions of dollars in penalties. An example was ITT that exported some night vision equipment to Vietnam and China back, almost a decade ago. And they were hit with a really big penalty. Most recently, Seagate was hit with a $300 million penalty for a big relationship with Huawei with regard to disk drives. So make sure you're compliant. You've got to have checks and double checks on your sales force, your salespeople. They want to get big commissions, but make sure you're doing so with regard to abiding by the laws of your country. Now, another term that's popped up recently that I've seen is trusted foundry or trusted IC source. So again, if the Department of Defense wants to use your wafer fab to make military wafers and chips, you've got to become a trusted foundry. And there's a group called the Defense Microelectronics Activities Office, and they control certifying the chain of custody. So both the classified and unclassified ICs that the military uses, there has to be no threat to the supply chain. So this is a supply chain issue at heart, but it's also retention of classified information. You can't modify or tamper with the ICs, the designs, the masks, the testing, the assembly services, etc. So those are the kind of things that to get be DMEA accredited, the manufacturer has to be aware of. Now, another topic that I occasionally see headlines are companies being placed on the banned entity list. And again, this started with DTE and Huawei back in 2018, that time frame, where more and more Chinese companies were added to this list by BIS. And if there was any ties to the PLA, the Chinese military, these big conglomerates that make smartphones or routers or servers, they were getting added to this list. And you can see a couple of them. YMTC, that's the NAND wafer fab in China. SMIC is a foundry, the biggest foundry in China for wafer fabrication. They have a big relationship with Huawei. DJI, biggest drone manufacturer in the world. They supply 50%, I think, of the consumer drones in the US. They're on this list. So even though we can buy their drones, we can't sell them parts without special permission from the US government. So in addition to the banned entity list, there's this unverified list where the US government can't prove that they're selling to the military, but they just haven't been verified that they are. And there's enough secrecy and hiding of certain records by countries for their own security reasons that it's really hard to prove whether or not particularly companies are selling, where they're selling their parts to, whether they're selling it outside to Russia, North Korea, Syria, etc., or they're using it in their own military. In October last year, there was a restriction put on U.S. citizens working in China at advanced wafer fabs. So if you are a maintenance technician or engineer working for ASML, you were a U.S. citizen, you were pulled out of the country in October and assigned somewhere else. You were no longer allowed to work on those advanced deep UV systems. This applies to logic ICs, technology in the 16 to 14 nanometer or less, and it can apply to just support people, maintenance people, preventive maintenance. You can no longer go into those facilities if you were a U.S. citizen. Now, China did respond. They've responded in multiple ways, just like the U.S. They started off with things like rare earth exports, on again, off again bans to Japan or other countries of rare earths, and rare earths are used in magnetics. Think of wind power, things of electric vehicles, anything with an electric motor that needs a permanent magnet. We've also seen most recently they banned or stopped shipping gallium and germanium, two interesting materials used in semiconductor sensors and semiconductor lasers. They also recently restricted graphite exports, which are used in batteries. And then about a week or so ago, they restricted the export of equipment used to refine and mine rare earths. So, a lot of Japan, US, some European countries, Australia, they're trying to start, mining and refining their own rare earths. They're going to have to do so on their own. They can no longer import Chinese refining equipment now. So, a lot of interesting tit-for-tat export controls being made by US, Europe, Japan, and China. And then just kind of summing up, you think of things like the CHIPS Act, you think of friendshoring, verified entities. It was interesting that some of the biggest fabs that are being built in the U.S. were being built by Samsung, by TSMC, by SK Hynix, and they wanted to get CHIPS Act money. However, they have wafer fabs in China, and they don't want to just close those wafer fabs. They want to be able to support them and continue to expand capacity. And for a while there, it looked like, in the CHIPS Act, you're not allowed to do that. You're not allowed to invest more than, like, say, 5% um, of your annual income into Chinese facilities, and certainly not with advanced semiconductors. So, TSMC and Samsung were playing a game with the U.S. government. And, hey, if you want these advanced nodes on your ground in your nation, you've got to be flexible with this. And sure enough, they were able to establish a verified end user designation. So you saw the unverified list. This is the verified list. And Samsung, SK Hynix, and TSMC were put on that list. They proved that they can control their IP. They proved that they could prevent that from leaking out at their Chinese fabs. And so they were given dispensation from the CHIPS Act restriction on investment in China, and are allowed to upgrade and expand their fabs there. And then finally, just export control alliances. You see friendshoring, you see things like the Chip 4 alliance. We're now starting to see almost export control alliances. And like I said, the Wassenaar Agreement is between 42 countries to prevent the escape of military dual-use technology to certain nations. Now there's this alliance with semiconductor tools and technology and wafers. ASML from the Netherlands agreed in 2019 to restrict EUV tools. This year they agreed to restrict some of their DUV tools. Japan also joined, telling TEL and Nikon to support this export banning alliance. So we effectively have this alliance related to exports to China that's ongoing. And if you enjoyed this topic, you want to go into this in more detail, or you want to talk about friendshoring and the CHIPS 4 Alliance, check out some of my videos or contact me at the website and email below. Thank you.